One moment while we go live. All right. But we're not picking up any video right now, so let me figure that out for a second. Of course, there's always got to be some technical difficulties. All right, let's try that. Hi everyone, Joe Fairley from Ascent Fab. Forgive the couple minutes of blank screen there. Again, this is live. This is off the cuff. This is something that I just enjoy doing and learning by the process of trying to do something live. So I believe by the streaming service that I'm using right now, some of the video might lag a little bit. So I'll go a little slow with what I'd like to show today. Happy Fabrication Friday for anyone who is out there and watching. Thank you again. Always appreciate anyone tuning in for our videos here. And so this week, I wanted to get into a little bit more depth on, again, going towards the educational side of what we'd like to do here at Ascent Fab and trying to make the digital workflows more accessible for clinicians in the field at the moment. So there are so many different 3D scanning technologies, digital modification softwares, and 3D printers. As you can see around me, I have a multitude of different printers around me. And it's those decisions based on what devices you want to print, how you want to print them, what materials you're going to use. And sometimes that can get a little overwhelming. I'd like to help kind of bridge that gap and go right down to the educational level as well. Thinking about starting up a kind of 3D printing boot camp this summer. So stay tuned for more information on a possible summer boot camp. If anyone is definitely interested in maybe a kind of 2-week long, we'll say live lecture series, we may start to take, O&P students, and students, I mean, of any age and experience in the field. If you're a student, you are, wanting to learn more about the digital workflows in O&P. So I'm going to be kind of hashing out those details a little bit more over the next couple of weeks and coming out with more information soon. So aside from that, again, getting into what I would like to present today with following up with one of the posts that I had this week, kind of further introducing some of the devices that we have available here at Ascent Fabrication. So what I've done is 3D printed out a replica of one of our customers' prosthetic sockets that we did for them in-house. And the workflow for that was the clinician sent me a 3D scan. The 3D scan was actually of the patient's inside current test socket. From that current test socket, I was able to extract out the model, the shape that I wanted from that device. And we were able to get alignment that way because the rest of the prosthesis was actually inside the scan as well. So from that, I was able to create the test socket. The test socket was going to include a foam flex air flexible inner socket with cushioned areas over the bony anatomy. So with the Foam Flex Air socket now, Foam Flex Air socket, again, this is our Foam Flex material. Get in touch with us for more if you'd like to start printing this yourself. The cushioned areas over the distal tibia, as well as the fibular head, these can be customizable per the patient in terms of size, shape, location, and as well as how cushioned that area actually is. So whether you want just a little bit of cushion, we kind of term that as to be medium, or if we want a lot of give in the device, it could be a soft cushion as well. I've seen a couple other prosthetic sockets out there that when people are showing you how much they can flex, a lot of it is from the outside in, right? They're showing you how much it can flex possibly in this way. If they have a cutout, they're showing you how much you can push into the device, but yet the patient's limb is inside the socket and you want to be able to push out, right, against that hard outer area. So our Foam Flex Air socket can integrate with any of your traditional componentry as well. If you wanted to do a 3D printed test socket in-house, we can send you that 3D scan to be able to print that. If you wanted to pull a traditional fabricated socket over the Foam Flex Air socket, we have workflows for that as well. And of course, a laminated socket. Again, we can customize the workflow to your clinic's needs. But so if we look a little bit further in detail on the Foam Flex Air buildup areas here, I'm pushing from the inside out, some cushion going towards this direction, right? So again, we can make that as soft or as kind of medium firmness as you would want. And we can integrate any distal componentry that you would want to as well. Currently, we have a couple different locks that are available to be able to, already put into our devices. If we don't have something in our library of componentry, we just ask for a couple simple measurements, and we can reverse engineer that part in our CAD systems, and then be able to integrate those components within your device as well. These sockets are airtight. We can do suction and vacuum with a number of different materials, which you'll see here today as well. Our second material that I showed in a post was the polypropylene preparatory socket. So currently, we have tested our sockets up to about 10 months now of use out in the field. And I'm happy to say that the polypropylene and our heavy duty materials have been withstanding the wear and tear that people have been seeing. We have a suggested use time of 6 months to give, again, a more out of office visit point of care for your patient to be able to kind of introduce them to a prosthesis, or if you need to get them into something a little bit more quickly and cost efficiently. The polypropylene does have a good amount of flexibility to it, but still stiff enough where you're going to have a lot of good support. It is more flexible than the PETG test socket. So that's a consideration when you're talking about the actual fit of the device. For all of our sockets, of course, through FDM or FFF printing, fused deposition modeling, FDM, or fused filament fabrication. We'll get into that distinction in a later video when we get more into the nitty-gritty of 3D printing in general. But they're the same basic concept of using filamented plastic to lay down layer by layer to produce the part. The layers are so fine at about 0.4, 0.5 millimeters in height that as a clinician, I don't have any qualms with trying to fit any of these devices and not be able to account for what might be maybe slightly more friction than a vacuum formed prosthetic socket, which of course is just completely smooth. We can account for that within our workflows to make sure that the fit of your device is consistent from test socket onto definitive. The polypropylene here is also slightly transparent, which is nice. But we can also have several different colors of the polypropylene from PP print. So looking at just a few other nice vibrant colors that we could have from the polypropylene. There's about 8 different colors that they have, which they've just come out with a very nice new light skin tone as well. So that'll be coming soon. And you can also, again, get that filament directly from us in order to print with that in-house. And we have good workflows that are more turnkey solutions so that we make it a little bit more easy on your staff to kind of lessen that learning curve for them. Getting into our kind of fourth material for the day now, looking at our, again, a more heavy duty because it's a little bit more structurally different than the polypropylene, I'll say. I'm expecting the polypropylene more than likely to wear out more quickly than our heavy duty material here. The heavy duty material is more stiff than the polypropylene, and this has also been post-processed for the highest mechanical characteristics for this material. So again, we have our Foam Flex Air socket that we're able to fit directly within all 3 of these sockets. And we do provide sockets that do have the trim lines cut out already for you as a service, or they don't need to be cut out. We can send the raw socket to you and you can cut it out yourself. However, you would like to do that. If you would like us to cut out the trim lines, I would please highly suggest that in your 3D, when you take your 3D scan and you have the patient there in front of you, if you're scanning the patients over their liner, then wrap their liner with a thin 1-layer wrap of clear plastic film, and then draw on there with black or blue Sharpie for us. And then we're downloading that 3D scan as an OBJ file. That OBJ file will allow us to see that color in the scan, and then we can directly translate those trim lines over to your definitive device, as well as any other bony anatomy for making the Foam Flex Air flexible inner sockets. We highly suggest that you indicate those on the 3D scan so that we're able to precisely place those cushioned areas for you. So again, just in a quick recap, we have the PETG test socket. We'll test that for clarity here. Not too bad over the camera. We can try to show some blanching, possibly. Yep, showing some blanching even through the camera. So very, very transparent material. Looking at our Foam Flex Air flexible inner socket. Nice, soft, lightweight, extremely versatile material. If this were not a locking system, if this were a suction system and we wanted a distal cushion built in as well, then you have 3 L codes that we suggest billing for this one prosthetic socket. Looking at the heavy duty material, again, for the preparatory socket, again, this is for at least suggested use for up to 6 months. And if it breaks during that amount of time within 6 months, we will warranty that. And finally, to the PP print polypropylene material, again, slightly flexible, comes in a myriad of colors to have a little bit more personalization for your patient. So something else that I'd like to talk about that we are currently in the works of promoting right now is our 3D printed silicone liner. That is in the beginning stages of a case study, which we're very excited to be working with a couple clinicians on. We're still looking for maybe a couple other participants in the study. We would like that to come from 5 individual clinicians. Currently, we have 3. So if you're interested in trying out a silicone below-knee cushion liner for your patient, please reach out to us and get into that case study with us. In the post earlier, I did show the first picture that I had of the silicone liner in that nice blue color. We can accommodate any color that you'd like, skin tone on up to any color of the rainbow for that. So really nice personalization aspects again into that design, as well as building up any cushioned areas also in that design. Another very kind of exciting announcement here, we are getting into lower limb orthotics as well. We've been kind of testing these behind the scenes a little bit now and coming out with some really great designs, specifically the nice blue polypropylene again from PP Print, and a Foam Flex Air flexible inner boot. So let's just take a look at this for a second. So both of these are 2 millimeters in thickness. The Foam Flex Air inner boot is extremely lightweight, and we can, again, build up any cushioned areas over bony anatomy that could be an issue longer term. So we could be pushing into, say, this malleolar area if we have any known issues with a certain patient. We're introducing the lower limb orthotics for pediatrics on up to adults. So get in contact with us to start using those devices with us today. Looking at the SMO design that we have here, very resistant to fatigue here at the foot plate. If we give you an idea of what that flex looks like, and with our dorsal wings, we're able to open that up nicely, and then having that wrap around the top of the foot there in order to help with some more control. We can design these exactly any way that you would want them to, right? So they don't have to have dorsal wings. They could have dorsal wings. We do have a couple of clinical, suggestions into some of the design features itself. But if there are certain customization aspects that you would want in an SMO for a kiddo, maybe you want the heel cut open. Maybe you wanted some other, again, cushioned area built within the Foam Flex Air design for the inner boot. Those can all be accommodated, and I'm really excited to start working with some of those clinicians who are seeing a lot of kiddos with SMOs. So we'll have more information about our SMO line of devices, as well as some ankle foot orthoses that will be coming out with a little bit more soon as I have some more good samples to show. But we can start ordering those today. So if you're, whether you're taking a 3D scan of a patient's limb, maybe you're using the COMAP, and maybe you have their new ankle foot orthosis stand jig to be able to scan on directly on the patient. That's wonderful. Then you can use that. Otherwise, you're taking a 3D scan of your plaster mold already, or just take a scan of the outside of the patient's cast. We would probably prefer the outside of the patient's cast, and we have a good workflow to go through making sure we get that nice intimate fit for your patient. So get in touch with us again today to try to start implementing lower limb orthoses out of polypropylene material. Again, these are heat moldable because it is polypropylene. Same type of features that you would see in a vacuum formed plastic draped polypropylene. Okay, so when you grind the edges down, the material is going to it's going to melt slightly. So it just takes a little finesse, a little nuance there with blending those edges in. but not any different than you would see with your typical ankle foot orthosis made out of polypropylene. Other considerations, we are working, we have a solid ankle AFO design already. We can accommodate some componentry. Right now we're working with Launchpad to get their components integrated with our lower limb orthotics. So Launchpad will be the first articulated design that we will be available to apply for your patients. We'll get in touch later on more if we kind of go down the line of the Tamarack joints as well. I know those are also very, very well used in the field, and people know them. But we're starting off with the Launchpad design. Any other features about if you wanted more personalization into this for kiddos? If we had something stamped into, kind of embossed or etched into this design, that could be possible as well if we go up to about 3 millimeters in thickness on the SMO. Again, these are 2 millimeters in thickness, so fairly thin and very lightweight. We're able to etch into the design at least something that's about 3 millimeters in thickness. You could have a butterfly stamped into it. You could have a race car stamped into it, maybe have the person's name stamped into it. Just some of more of those personalization features along with the really nice bright colors. So that would be a lot of what I can talk about today for our new, lower limb orthosis design offerings. Again, you can go to our website. Right at the top of the homepage is submit to our work order. If you would like to talk about any of these designs prior to submitting a work order, we absolutely suggest that as well. Please get in touch with me via email at joe@ascentfab.com, on LinkedIn, or through our website on the contact page. You can also book some time out with me one-on-one to go through exactly what your particular workflow would be in-house as well. So I wanted to also say that this weekend is Mother's Day. Happy Mother's Day to everyone. My grandmother is in town, and she's here with me today, and showing her around Ascent Fab. And we're going to have some nice family time this weekend. So I hope you and your family also have that nice time. Happy Mother's Day to every mother out there. And again, have a great weekend, everyone. With just a few more minutes left in this broadcast here, maybe just also highlighting again how maybe we are going about testing some of these devices. So for the amount of time that these have been in use so far, we would suggest working with us extremely closely, right? This is clinician to clinician. As a clinician, I would feel comfortable putting my patient out on this device today. We have not mechanically tested this. A lot of our devices have not been cyclically tested mechanically, although they should. And we will get to that point, of course. And if we look at historically in the field, how our devices have evolved and have been tested is in very, very rigorous, tight environments with the correct personnel on hand, having those certified prosthetist, orthotist, maybe some rehabilitation specialists involved with making sure that new devices are going to do what we think they're going to do for patients. If there's ever a concern about one of our devices, we will absolutely, work with you to make that right. Being able to redo devices for no cost, or if something breaks, we want to know exactly how it's going to break so that we can better off help design something better in the future for you. We will be doing some more rigorous initial clinical trials here with some of our clinical partners, and really good patients who are going to be able to give us feedback on some of these devices as well. So we've done our due diligence with design features, with materials, with some simulations, and into some of our clinical testing that, again, any device that I put out as a product, I am more than happy with and comfortable putting this onto a patient and saying this is a more end use definitive device. We've got Taiwo here in the comments. I see you, Taiwo. Thank you very much for hanging out with me today. So we've got a question: can an FDM printer print the foam flex inner part of the SMO? So yes, all of I should say most of our printing currently is done with FDM processes. So we do all this, all the FDM printing in house. This foam flex air design is FDM printed. So yes, Taiwo, we can do this through most printers in most cases on your machine. So this material is a little finicky and does take a lot of calibration in order to do it correctly. So I would suggest, if you want to use the foam flex material, excuse me, to be able to reach out to us so that we can get you set up, because it does take some considerations. Taiwo, I know that you're talking to us from Africa, and we know that with some of our materials, they do take moisture from the environment quite readily, right? This is one of those materials. We do have to have this material very dry in order to print with it. So that's a consideration when we talk about, what materials we might or might not be able to successfully print all the time in environments that are more humid and hot. The Print Dry Pro, Taiwo, if you see that up there on top of the PVA Med printer, the Print Dry Pro can be purchased from Matter Hackers. Or we can also show you a link to purchase that directly through our website to be able to get the exact parts that you would need. Think of that as more of a sourcing shop rather than a reselling shop at the moment. I'm not licensed as a reseller for the Print Dry Pro, but we will help you purchase that if needed. The Print Dry Pro is excellent at taking out that moisture from filament that's been sitting around for a while. That product there, I believe, is around $200. I have to go back and check that, but around $200 for the Print Dry Pro. You can use it as you're printing, which I frequently do with the foam flex material. And you can also dry your filament when you're not printing with it. So we would highly suggest trying to keep your filament dry. When we talk about what is dry and what is wet, I do have a humidity sensor here in my office that will tell me the percentage of humidity that's in the room. And anything under 40% humidity is pretty good. Anything under 30% humidity is much, much better to print with. 20% is great. It's amazing, right? Which you may or may not have in your location. So we'll get into more nitty details on more of those 3D printing questions in another video. But again, I would like to say that the polypropylene is not hygroscopic. So it will not take up moisture from the air. So a really nice material that you can have lying around in a hot, humid environment. And it will not react the same as other materials that might pull in moisture from the air. So really versatile material. Taiwo, I'll chat with you later in terms of maybe how to try to get you a spool of the PP print material, and we can kind of go from there. So yeah, thank you guys again for sitting with me for a half hour. I appreciate anyone who's willing to hang out with us and to learn. Again, I will be looking at some more details in terms of how to offer a kind of summer boot camp for 3D printing and digital design within O&P. So listen in and tune in for those details later on in the next couple of weeks. I'll have some more details on that. Other 3D printing questions, feel free to reach out. I know there's a couple others in the field who are also trying to forward this part of the field. So, kudos to them. And remember, it's going to take a team for all of us to collaborate together to forward the field in this area. So thank you again, everyone. Joe from Ascent Fab here today, May 6th. Happy Mother's Day out there to everyone. All right. Have a great weekend.